In last class, we started our discussion with basic methods, basic techniques of proofs. So we discussed whenever we are going to have some solution of certain problem, of certain algorithm, we are going to develop an algorithm. So we have to show to the people that this solution is correct. So nobody is going to believe if we just say, this is my solution, so this is correct. We have to show it by giving a formal method to make it evident, clear to everyone that it is correct. So this method is called proof. So we have to prove it that our statement, our claim is correct. It's true, it's correct. So in scientific language, the claim is called conjecture, and when we prove this conjecture, it becomes a theorem. So we have to prove conjectures and then they become theorems. So whenever we are going to claim something, whenever we are going to give a solution, so we have to prove our conjecture. So proof of course जो हमारा conjecture होता है, it's going to be a proposition. Proposition, remember those statements which could be true or false. So to make it true, so we have to follow certain steps, logical mathematical steps, and that will lead us to our conclusion that it is true. In our high school and middle school, we often have to prove some identities, equations. उसमें क्या होता था कि left hand side should be equal to right hand side. या inequality हो तो it is greater than or it is less than right hand side. So उसमें हम करते क्या थे कि हम left hand side को लेते थे, then we follow certain steps. उसमें हम कुछ algebraic step कर रहे होते थे, simple arithmetic steps कर रहे होते थे, and finally we reach to right hand side. So हमारी assumption ये होती थी कि left hand side is our statement which is correct, and we have to follow certain steps, mathematical, algebraic steps, arithmetic steps, which will lead us to right hand side. So we make a conclusion that left hand side has become equal to right hand side. So our identity is proven, our equation has been proved. So इस तरीके के proof को हम कहते हैं direct proof. When we take one thing and we follow certain steps and we reach to our conclusion. So most of the time we have implication. If we have some hypothesis, then we are going to have our conclusion. So we start from our hypothesis. जो हमारी assumptions होती हैं, हमारी hypothesis है, हम वहाँ से start करते हैं. Then we follow some definition, facts, mathematical facts, logical steps, arithmetic, algebraic steps, and obviously these steps should be those steps which will help us to lead towards conclusion. कि हम conclusion तक पहुँच जाएं. So we start from our hypothesis and we reach to our conclusion. So इसके दरमियान में जितने हमारे steps हैं, those are those steps जिसको देख के everybody will be convinced कि yes, when we start from is our hypothesis, following these steps we can reach to our conclusion. So our statement, our conjecture is correct. It's there is nothing wrong in it. Everything is correct. So it is proven. Our conjecture is true. So whenever we are going to have solution, it should be correct. और correctness की measure क्या है, इसकी evidence क्या है, it's proof. So that's why we are going to have proof. So last class में we did two kind of proofs. Actually it was one proof and one disproof. Proofs हम direct method of proof कि हम अपने hypothesis को लेके चलते हैं and then we reach to our conclusion following intermediate steps. So that was direct method of proof. दूसरी चीज जो हमने की थी, that was counter example. कि एक claim दिया हुआ है, उसको हमने refute करना है, उसको हमने deny करना है कि this claim is not true. So usually एक generalized claim दिया जाता है कि this is true for all of this. एक universe of discourse जो हमारा domain set है, उसके अंदर ये claim true है. And if we can find one example that will counter this claim, जो इस claim को falsify कर दे, इसको गलत साबित कर दे, एक example will be enough. तो वो उसमें हम फिर ये नहीं कह सकते कि देखें for all elements, this claim is true. We can say, see over here, uh, this this element belong to our discussion, our domain set, and for this your claim is not true. So you cannot claim that it is true for all the elements in our domain set. So वो एक counter example बन जाएगी which will counter the claim. So this is like called disproving of the claim. हम disprove कर सकते हैं counter example से. Counter example could be many counter example, लेकिन एक counter example देना काफी होता है to refute the claim, क्योंकि उसमें हम universal quantifier use करेंगे for all elements is true. So एक भी अगर हमें there exists something for which it's not true, हमें एक भी ऐसी example मिल जाए for which the claim is not true, so it's enough to disprove it. So let's start the lecture by solving some examples, some more examples of direct proof. So these examples were given in the last lecture that you can attempt it. Let's try to solve these. So first one is sum of two rational numbers is a rational number. अगर हम दो rational numbers को आपस में ऐड करें तो उनका जो sum है that is also a rational number. Remember the definition of rational number. Rational number ऐसे नंबर होते हैं जो दो इंटीजर्स की रेशियो की शक्ल में लिखे जा सकें, जैसे 2/3, 3/1. जो हमारे इंटीजर्स होते हैं वो भी रैशनल नंबर होते हैं, लेकिन इंटीजर्स की रेशियो को हम रैशनल नंबर कहते हैं. तो हमारे पास कोई भी दो रैशनल नंबर हो, अगर उसको उनको हम ऐड करेंगे we will get a rational number. So let's try to prove it. So let we have two rational numbers n1 and n2. Let's call n1 is going to be a ratio of two numbers. So let's call n1 as a/b and n2 as c/d. So both n1 and n2 are rational numbers. So a/b, c/d, a, b, c, d. ये हमारे पास कोई भी integers हैं. This could be positive integers, negative integer, anything. With the exception, आपकी denominator में zero नहीं आना चाहिए. So we should write it down over here that b and d are not equal to zero. क्योंकि अगर वो zero हो गया तो हमारे जो number हैं n1 और n2 वो infinity हो जाएंगे. So rational numbers, I mean we cannot handle with infinity, so we avoid infinity. So we give exception कि b and d जो denominator के number हैं वो zero नहीं होना चाहिए. So a, b, c, d are integers and the denominator terms b and d are not zero. n1 and n2, these are two rational numbers. So sum of these two integers, sum of these two rational numbers, sum of these two let's write down rational numbers. इन दोनों को जब हम sum करते हैं n1 plus n2, so this is going to be a/b plus c/d, a/d plus c/d. So हमारे पास a/b plus c/d हैं, इनको हम LCM ले सकते हैं. BD is our LCM. So in denominator we have BD, numerator में क्या आएगा a times d plus b times c. Simple हमारा जो arithmetic है solving fractions को. So AD plus BC over BD. AD is a product of integer. Whenever we multiply two integers, we are going to get an integer. So AD, BC, BD, these become integers. And whenever we add two integers, we also get integer. These are some basic facts, basic definitions that we know. We don't need to prove it. Everybody knows this thing. Even we can prove it, but over here, I mean, we don't need to prove it. It's known. So we can say numerator में भी हमारे पास integer है, denominator में भी integer है. So this is going to be a ratio of two integer. जहाँ पे मैंने AD plus BC जो numerator की term है उसको I call it X, और जो denominator की term है BD, let's call it Y. So this become X over Y. So it's a ratio of two integers. So if it is the ratio of two integers, it means this is going to be a rational number. So that's what we were going to prove. That sum of two rational numbers is going to be a rational number. So this was straightforward. जब भी हम दो rational numbers को add करेंगे, we will get a rational number. इस तरह अगर दो rational numbers को आप उनके difference लें, so difference is also going to be a rational number. And similarly, if two rational numbers are multiplied to each other, we also get a rational number. And if two rational numbers are if one rational number is divided by other rational number, so if we perform division between two rational numbers, still we get a rational number. So proof method will be just similar to this one. So rational numbers को handle करना, I mean, it's quite straightforward. Next, show that the additive inverse or negative of an even number is an even number. I mean, it's quite obvious, but we need to formally prove it. अगर हम कोई भी नंबर लें उसका एडिटिव इनवर्स क्या है कि एक नंबर को अगर हम इसके एडिटिव इनवर्स में ऐड करें, a number plus its additive inverse, so we get additive identity which is 0. So जैसे कि 2 नंबर है, 2 का एडिटिव इनवर्स इज -2, 3 के एडिटिव इनवर्स इज -3, 1 के एडिटिव इनवर्स इज -1. सो हमारे पास कोई भी नंबर है, अगर तो नंबर इवन है तो उसका एडिटिव इनवर्स भी इवन होगा. Obviously, if like for 2 to 2 का additive inverse is -2. Let's prove it. So if we have a number, let n be an even number, so we can write down n is equal to 2k. So n is an even number, so we can write it down n as multiple of 2. So where k is some integer, कोई भी integer है उसको जब हम 2 से multiply करेंगे, so the new number will become an even number. So n is equal to 2k is an even number. Then its additive inverse of n is going to be -n. So n minus n is equal to 0. So n additive inverse is -n. So let's look at -n. -n where n is equal to 2k. So -n is going to be -2k. यहाँ से भी obvious नजर आ रहा है कि it's multiple of 2. लेकिन चले हम 2 को बाहर लिख लेते हैं. So 2 times -k. So it's multiple of 2. So -n is a multiple of 2. So it's a multiple of 2. Hence, it's also an even number. So an additive inverse of an even number is also even. From here, we can also make a corollary. एक result हम deduce कर सकते हैं. It's easy to show कि जब हमारे पास एक odd number है, तो उसका inverse भी, additive inverse भी एक odd number होगा. So additive inverse of an even number is even, and additive inverse of an odd number is odd. Let's do another example. If x is rational, then 1 over x is also rational. And we over here may claim that x is not equal to 0, because if x is 0, then 1 over x is going to be something that we cannot handle. It's going to be something infinity. So if x is rational, then its reciprocal is also rational. So reciprocal number is called multiplicative inverse. Multiplicative inverse, because when we multiply x with its multiplicative inverse, we get multiplicative identity, which is 1. So x times 1 over x, we know it's 1, which is multiplicative identity. So एक rational number का inverse multiplicative inverse rational होता है. x का multiplicative inverse 1 over x is also rational. So let's x be a rational number. If x is a rational number, so it means it's the ratio of two integers. So we can write down x is equal to p over q. आप इसको a over b, x over y कुछ भी लिख सकते हैं. So where p, q are integer, so it's the ratio of two integers. फिर हमारे पास 1 over x क्या होगा? So 1 over x is going to be 1 over p over q. X is p over q, so 1 over x should be p over 1 over x is 1 over p over q. या हम इसको q over p भी लिख सकते हैं. x 1 over x is going to be q over p. p q integer थे, so q over p is again a ratio of two integers. हमारे पास p और q दोनों integers हैं. So पहले हमारे पास ratio p over q थी, तो अब ratio हमारे पास q over p है. It's still a ratio of two integers, so it's a rational number. So जब भी हमारे पास एक rational number है, उसका reciprocal भी एक rational number है. So also we can see if x is rational, then its additive inverse minus x is also rational. Let's do another example. This is an interesting example. Use a direct proof to show that every odd integer is the difference of two squares. हमारे पास जब भी कोई odd integer होगा, so this is going to be a difference of two square number. स्केयर नंबर आपको याद लास्ट क्लास में हमने डिस्कस किया कि स्क्वायर नंबर, परफेक्ट स्क्वायर्स वो नंबर होते हैं जो किसी नंबर के स्क्वायर होते हैं, जैसे 1 was 0, 0 is square of 0, so 1 is square of 1, 4 is square of 2, 9 is square of 3, and 4 is square of 16 is square of 4, 25 is square of 5, and so on. So ये हमारे पास perfect square है. Claim is कि whenever we have an odd integer, this is going to be difference of two perfect squares. जब भी हमारे पास एक odd integer है, इसको हम express कर सकते हैं difference of two square numbers के साथ. For example, अगर 1 is हमारे पास odd number है, so 1 को हम लिख सकते हैं 1 square minus 0 square. So 1 का square minus 0 का square. So this is true. 3 को हम देखें, 3 is going to be difference of two square numbers. So this is going to be 4 minus 1. 4 is perfect square, 1 is perfect square. So 3 is 2 square minus 1 square. 3 is equal to 4 minus 1. 5 is 9 minus 4. 9 perfect square, 4 perfect square. 7 is 16 minus 9. 9 is 25 minus 16. 11 is 36 minus 25, and so on. So it's अगर हमने अपने intuition देखने के लिए we can see for some numerical values, लेकिन जब हम proof करते हैं तो proof में हम numerical values नहीं देते. Proof एक generalized proof होता है, so we cannot say कि see it's true for these 5, 6, 7 examples, so it's always true. So we have to make a generalized proof. So over here we can see, so if we have an odd integer, then it's going to be difference of two square. So let's take an odd integer. So let's n is equal to 2k plus 1. So this is an odd integer, n is equal to 2k plus 1. So we have, हमारा goal क्या है कि it should be something in this form, कि एक square हो और minus एक और कोई square हो. इस तरह की शक्ल में हम इसको लेके आना चाह रहे हैं. So n is equal to 2k plus 1. So over here we can see कि हमें एक square तो नजर आ रहा है. 1 is complete square. लेकिन हमारे पास दूसरा square नहीं है. So actually this is a problem of completing square. अगर हम एक complete square कर लें जहाँ पे हमें 2 भी नजर आ रहा है, so this is going to be like n is a plus b whole square. इस तरह की कोई शक्ल है इसकी. A plus b whole square, remember it's going to be a square plus 2 times ab plus b square. We see over here 2 times ab कुछ हमें नजर आ रहा है. b square, 1 square is 1. A square की चीज missing है, so it should be in terms of k. So this is a problem of completing square. We need to add something, and whenever we add something, we have to subtract something, the missing term for completing square. So if we look at it again, n is equal to 2k plus 1. So 2k can be written as 2 times 1 times k, and 1 can be written as 1 square. 2 times 1k plus 1 square is 2k plus 1. यहाँ पे it's just like 2 times a times b plus b square, और a की टर्म क्या बन रही है? This is k. So अगर हम इसमें k square ऐड करें, so this will become a complete square. So if we add k square, so we have to subtract k square as well, ताकि equality पे कुछ फर्क ना पड़े. So if we add k square, it becomes k square plus 2 times 1 times k plus 1 square. It's just like a plus b whole square. A square plus 2 times ab plus b square. और इसमें से हम फिर minus k square कह रहे हैं, कि हमने k square ऐड किया तो minus k square भी हमें करना पड़ेगा, k square को minus भी करना पड़ेगा. So k square plus 2 1k plus 1 square. So this is going to be k plus 1 whole square, and then we have minus k square, so it's minus k square. So n is equal to k plus 1 whole square minus k square. So it's difference of two squares. एक हमारे पास square k plus 1 का है और दूसरा k square का है. So the claim is true. If n is an odd integer, so n can be expressed as difference of two squares. सो यहाँ पे हम ये भी देखते हैं, आई मीन वी कैन मेक ए corollary फ्रॉम हियर कि any odd integer is difference of two consecutive squares. एक k का स्क्वायर है और दूसरा k plus 1 का स्क्वायर है. So we can see like 9 is difference of 5 square plus 4 square. 25 minus 16 is 9. So 5 or 4 का square. Similarly 11 is difference of 6 square and 5 square. 36 minus 25. And 13 is difference of 7 square minus 6 square. 7 is 49 minus 6 square is 36. So जब भी हमारे पास कोई odd number है, so it will be difference of not only two squares but those two squares are consecutive squares. एक k plus 1 का square है, दूसरा k का square है. And this was an interesting result. So again, I repeat how we do it. We take an odd number, or odd number is 2k plus 1. We do completing squares, completion of squares. We add k square and we subtract k square. So जब k square को add किया, so we'll get k plus 1 whole square. और दूसरी टर्म हमारे पास already आ गई minus k square. So this is going to be a difference of two squares. Next example is show that these three statements about an integer x are equivalent. पहली statement है 3x plus 2 is even. दूसरी statement है x plus 5 is odd. Third statement is x square is even. So इन तीनों को हमने equivalent show करना है. It's just like by condition. Instead of by condition, we have now by condition में हमारे पास two statements होती हैं. कि पहली statement implies second, दूसरी statement और दूसरी statement implies first statement. Now we have three statements. So it's like a circular condition. If you show circular condition, then they are equivalent to each other. One implies two, two implies three, and three implies one. अगर हम ये तीनों चीजें शो कर दें कि one implies two, and then two implies three, and then three implies one, ये तीन implication बन रही हैं. पहली implication one implies two, दूसरी implication two implies three, और तीसरी implication वापस circular three implies one. So ये तीनों आपस में एक ही सर्कल में चल रही हैं. So it means all three statements are equivalent to each other. Equivalence show करनी है, so we can show these three implications. If they holds, then it means all three statements are equivalent to each other. तो पहली को हम देखते हैं. One implies two. So 3x plus 2. If 3x plus 2 is even, then x plus 5 is odd. So अगर 3x plus 2 even है, let's take it. Let 3x plus 2 is equal to 2k. So it's an even number. Then what will be x? अगर हमें x का पता चल जाए, we can say x plus 5 क्या होगा. So 3x plus 2 is 2k. So we can write down 3x as 2k minus 2. So we can see 3x is equal to an even number. From here actually we can conclude x is even, but अभी हमने वो चीज नहीं की. So let's see. 3x is equal to 2k minus 2. 2k minus 2 is even number. लेकिन x क्या है? X is going to be 2k minus 2 over 3. It's ratio of two numbers. अब जब हमारे पास even जो odd number होते हैं, these has to be integer. We cannot have it in the form of ratio. अगर ये रेशियो में है, so we cannot say whether this number is going to be an integer or not. देखिए अगर ये 12 over 3 है, फिर तो ये integer होगा. 12 over 3 is equal to 4. लेकिन अगर ये 14 over 3 है, then it's not going to be an integer. Even or odd number, they have to be integers. So from here we cannot say anything about x. There is a problem. We are going to have a ratio about which we cannot say whether it is integer or not. So maybe we can start from 2 implies 3. So then we see what happens, and then 3 implies 1 and 1 implies 2. So actually there is way to prove this thing जो हम lecture के end पे हम देखेंगे कि if 3x plus 2 is even, x plus 5 is odd, उसको हम एक और तरीके से कर सकते हैं, लेकिन अभी हमने वो सीखा नहीं. So we skip this thing. We try to do 2 implies 3. हम instead of starting from 1 implies 2, हम start करते हैं 2 implies 3 से. Let's try to prove 2 implies 3. 2 implies 3 क्या होगा? if x plus 5 is odd, then x square is even. If x plus 5 is odd, then x square is even. Let's see. X plus 5 is equal to an odd number 2k plus 1. हमारे पास x plus 5 आ गया. यहाँ से हम x को निकाल सकते हैं. x is equal to 2k plus 1 minus 5. x is 5 का हम इक्वालिटी की दूसरी साइड पे लेंगे, so it become 2k plus 1 minus 5. Plus 1 minus 5, it's minus 4, so x is equal to 2k minus 4. So 2 को हम यहाँ से कॉमन ले लें, so it's going to be 2 times k minus 2. So it's multiple of 2. मैंने k minus 2 k prime लिख दिया. So x is equal to 2 times k prime. It's multiple of 2. So we can say x is an even number. X is an even number. This is interesting result. We should highlight it. We can use it again. X is an even number. Okay. If x is even, then x square is even. We know this thing. हमने last class में ये prove किया था. If n is an even number, then n square is even. So if x is even, then x square is even. X even है तो x means x is equal to 2 times something. हमने देखे is 2 times k prime. So x square क्या होगा? 2 times k prime square. So this is going to be 4 times k prime square. हम इसको या हम इसको we can just express it as prime square. Okay, so this can be written as, okay, fine. So 4 times k prime square. 4 is 2 times 2, so 2 times 2k prime square. So it's multiple of 2. 2 times something, so it's an even number. So x square is even number. So हमारी ये implication 2 implies 3. X plus 5 is odd, then x square is even. We have proven this thing. So let's now prove 3 implies 1. और उसके बाद फिर हम 1 implies 2 करेंगे. So 3 implies 1 means if x square is even, then 3x plus 2 is even. हमने अपनी पिछली implication से हमारे पास ये result आ गया कि x is an even and x square is even. We have x as even number and x square भी हमारे पास even number है. So let's take x is equal to 2k. X is equal to 2k. तो फिर हमारे पास 3x plus 2 क्या होगा? 3 times 2k plus 2. 3 times 2k, x की value, x is even number, plus 2. So this becomes 6k plus 2. From here we can take 2 as common. 2 is multiple to both, so 2 बाहर आ गया. 2 times 3k plus 1. So again 3x plus 2 is equal to 2 times 3k plus 1. It is multiple of 2. It is a multiple of 2, hence 3k plus 1. 3x plus 2 is even number. So 3 implies 1. It holds. No, जो हम शुरू में नहीं कर सके थे 1 implies 2. No, try to do this thing. अब हमारे पास ये पता है कि x is even number. So let's try to do it. And now we know x is even, x square is even, 3x plus 2 is even. These results are known to to us. Let x is equal to 2k. तो फिर x plus 5 क्या होगा? X plus 5 is going to be 2k plus 5. Odd number के लिए हमें चाहिए plus 1. तो plus 1 हमें 5 से मिल सकता है because 5 can be written as 4 plus 1. So this one will serve our purpose. हम remember हमने कहा था हम logical steps, mathematical steps वही लेंगे which will help us to lead towards our conclusion. Conclusion हमारा यही है कि x plus 5 should be odd. So we need plus 1 because odd number are 2k plus 1. इस की फॉर्म में लिखे जाते हैं. So we need plus 1 here. तो शुरू में हमारे पास क्या है? 2k plus 4 and then plus 1. 5 is written as 4 plus 1. So we have got 2k plus 4 and then plus 1. 2k plus 4. 2k plus 4 में से हम दो कॉमन ले सकते हैं. 2 is taken as common. So 2 is a common multiple. 2 times k plus 2 plus 1. K plus 2 का k prime लिख लें. So 2 times k prime plus 1. So this is form of an odd number. Multiple of 2 plus 1. So this is an odd number. X plus 5 is odd number. So we have shown 1 implies 2. as well. So हमने तीनों implications show कर ली. 2 implies 3, 3 implies 1, and 1 implies 2. So it means all these three statements are equivalent. 3x plus 2 is even, x plus 5 is odd, and x square is even. तीनों statements एक ही message convey कर रही हैं. Eventually that message is x is even. Let's do some exercises of counter example. Counter example may we need to just give one example to refute the claim जो हमारे पास proposition है उसको हमने अगर show करना है कि this proposition is wrong, a counter example should be enough. So let's see. पहला problem है find a counter example to the statement that every positive integer can be written as sum of the squares of three integers. कि किसी भी हम इंटीजर को तीन स्क्वायर्स की शक्ल में लिख सकते हैं, सम ऑफ थ्री स्क्वायर्स लिख सकते हैं. फॉर एग्जांपल अगर हम जीरो को देखें वो तीन इंटीजर एक से भी हो सकते हैं. फॉर एग्जांपल ओके वी आर टॉकिंग अबाउट पॉजिटिव इंटीजर्स, सो वन कैन बी रिटन एज वन स्क्वायर प्लस जीरो स्क्वायर प्लस जीरो स्क्वायर. So it's sum of three square numbers. So any number n, any positive integer n can be written as sum of three squares integer, three integer squares. So one हमें पता है one can be written as one square plus zero square plus zero square. Similarly for two can be written as one square plus one square plus zero square. That's true. How about three? 3 can be written as 1 square plus 1 square plus 1 square. So we can write down 3 as, so 3 can be written as 1 square plus 1 square plus 1 square. That's true. 4 can be written as 2 squares plus 0 square plus 0 square. That's also true. So 4 can be written, sorry, 4 can be written as 2 square, which is 4, and then 0 square plus 0 square. How about 5? 5 can be written as 4 plus 1 plus 0. So 5 के लिए भी ये claim true है. 5 can be written as 2 square, which is 4, plus 1 square, which is 1 plus 0. So 6 can also be can be written as 2 square, which is 4 plus 1 square plus 1 square. How about 7? 7 को हम क्या लिख सकते हैं इस फॉर्म में? 7 we cannot if we write down 3 square, 3 square is going to be 9. 3 square तो exceed कर जाएगा. We cannot use 3 square. 2 square plus 1 square plus 1 square is 6. अगर 1 square की जगह हम 2 square use करते हैं तो 2 square plus 2 square is going to be 8. तो ये 7 से exceed कर जाएगा. So for 7 we cannot write down, we cannot express it as square of 3 integers. 7 में हमें कोई ऐसे 3 इंटीजर नहीं मिलते जिनका हम स्क्वायर और फिर उनको ऐड करें तो वो 7 के बराबर हो. So 7 is a counter example. हमारे पास 7 एक counter example है, and after 7 we can find more counter examples as well, but one counter example is enough. एक counter example देना काफी है. 8 can be expressed, 9 can be expressed, and so on. 10 can be expressed. So लेकिन एक काउंटर एग्जांपल देना काफी है. काउंटर एग्जांपल के लिए इफ वी हैव सम प्रॉब्लम, जिस जहां तो हमने देखा हमने एक करके हमने इंटीजर्स को ट्राई किया और सातवें इंटीजर पे हमें एक काउंटर एग्जांपल मिल गई. सातवें केस में हमें काउंटर एग्जांपल मिल गई. सर्टेन प्रॉब्लम्स होते हैं जिनके लिए काउंटर एग्जांपल इतनी आसानी से शुरू के इंटीजर्स में नहीं मिलती. उसके लिए वी कैन राइट डाउन ए कंप्यूटर प्रोग्राम. सो हो सकता है आपका 50th केस पे 40th केस पे hundredth या thousandth केस पे आपको काउंटर एग्जांपल मिले. So we can simply write on a computer program which will check one by one each case till we find a counter example. Okay, so let's look at the next problem. Disprove the following statements by finding a counter example for each of them. First statement is for all real numbers A and B. I mean, this is the claim says for all real numbers, if we take any two real numbers A and B, if B square is greater than A square, then B is greater than A. अगर स्क्वायर बड़ा है तो फिर वो नंबर भी एक दूसरे से उनके दरमियान भी ये रिलेशनशिप एग्जिस्ट करेगा. अगर B स्क्वायर ये वाला स्क्वायर A स्क्वायर से बड़ा है तो फिर नंबर B भी A से बड़ा होगा. Just like 25 is greater than 16, so 5 should be greater than 4. 25 is greater than 9, so 5 should be greater than 3. Yeah, 36 is greater than 4, so 6 should be greater than 2. So we have to find a counter example for this thing. Let's see. So let's say 25 is greater than 9. We know 25 is greater than 9. So can we say okay, square root of 25, which is apparently which is 5. So 5 is greater than 3. So can we say that 25 square root is greater than square root of 9? But we know square root of 25 is not only plus 5, it's also minus 5. Plus 5 को आप square करें, we will get 25. Minus 5 का अगर हम square करें, still we get 25. So square root of 25 is plus 5 and minus 5. Similarly, for 9, square root of 9 is plus 3 and minus 3. So statement ये कह रही है कि B square is greater than A square, then B should be greater than A. अगर 25 9 से बड़ा है तो इनके स्क्वायर रूट भी के दरमियान भी ये ग्रेटर देन के रिलेशनशिप होना चाहिए. अगर तो हम स्क्वायर रूट प्लस 5 और प्लस 3 लें फिर तो ये चीज होल्ड करती है. लेकिन अगर हम इनके स्क्वायर रूट माइनस 5 और माइनस 3 लें then this thing will not hold because minus 5 is less than minus 3. या अगर हम एक साइड पे माइनस 5 ले लें दूसरी साइड पे प्लस 3 ले लें, so this thing will not hold. So if we take minus 5 and minus 3, so minus 5 is less than minus 3. Minus 5 is not greater than minus 3. अगर हम नेगेटिव नंबर्स ले लें तो फिर b greater than a का रिलेशनशिप एग्जिस्ट नहीं करेगा. उस केस में b square is greater than a square, लेकिन b will be less than a. For negative numbers, this relationship does not exist. So we have many counter examples. So all those negative numbers will be negative integers will be counter example for this thing. Next is for all real numbers x, y and z. If x is greater than y, then x times z is greater than y times z. Real numbers के लिए अगर तो x y से बड़ा है तो अगर हम दोनों साइड पे z से मल्टीप्लाई करें, inequality will still hold. So can we find a counter example for all real numbers? So over here we can see कि अगर हम z को नेगेटिव नंबर ले लें, so x times z will be less than y times z, क्योंकि नेगेटिव नंबर से मल्टीप्लाई करने से inequality आपकी चेंज हो जाती है. फॉर एग्जांपल, if x is 3 and y is 2, so 3 is greater than 2. लेकिन but if we take z as -1, z को हमने -1 ले लिया, so जब हम -1 से मल्टीप्लाई करेंगे, we cannot say -3 is greater than -2. -3 is less than -2. So 3 times -1, which is -3, is less than 2 times -1, which is -2. So एक नेगेटिव नंबर से मल्टीप्लाई करने से ये चीज होल्ड नहीं करेगी. अगर स्टेटमेंट ऐसी होती फॉर ऑल पॉजिटिव रियल नंबर्स x, y and z, if x is greater than y, then x is greater than yz, उस केस में ये स्टेटमेंट ट्रू थी. लेकिन हाँ पॉजिटिव नंबर्स की नहीं बात हुई. फॉर ऑल रियल नंबर्स, तमाम रियल नंबर्स के लिए क्या ये इनइक्वालिटी होल्ड करती है? सो आंसर इज नो. काउंटर एग्जांपल क्या है? देयर आर लाइक इनफाइनाइट काउंटर एग्जांपल्स. whenever z is a negative number, so this inequality will not hold. उस केस में आपकी इनइक्वालिटी का साइन उलट जाता है. नेगेटिव नंबर से जब भी हम मल्टीप्लाई करते हैं, इनइक्वालिटी रिवर्स हो जाती है. सो दिस इज आवर counter example. So these were some examples, exercises about direct proof and disproving by counter example.